Okay, so hello everyone, and thank you for coming to another installment of our Author Talk series. Today we're joined by Marc Schaus, who will talk about the ideas from his upcoming book titled Our Livable World, Creating the Clean Earth of Tomorrow. This event is hosted by the Centre for Inquiry Canada, your community for science and secularism. My name is Rohit Mohindra, and I'm the Toronto branch manager and a board member for CFIC. We are Canada's only national nonprofit with the mission of promoting and educating the public on critical thinking, science, and secularism. We help people make decisions based on evidence, rational thinking, and compassion. Therefore, in line with our mission statement, is to hold events like these, where we provide a venue for subject matter experts, intellects, and free thinkers to engage with you. In order to put on events like these, we heavily rely on donations and memberships. Please consider this as you enjoy the talk, which I'm very excited about. Here's a bit of background about the speaker. Marc is a professional research specialist and science writer. He is the author of Post-Secular, Science, Humanism, and the Future of Faith, which I'm sure many of you have read, and has written articles that have appeared in Arrow Magazine, Free Inquiry Magazine, The Huffington Post, and Pathos. His new work, Our Livable World, Creating the Clean Earth of Tomorrow, will be out in October through Diversion Books. He currently resides in Kitchener, Ontario. So the agenda is as follows. We will start the talk momentarily, and we will go till about 9 o'clock or so, and then we will have Q&A. Like I mentioned, I'm going to keep everyone's microphone muted. If you have a question, you can raise your hand, and I will take notes of who has their hand raised. And I will unmute your microphone, and then you can go ahead and ask Marc your question. In the chat window as well, I will place the link where you can pre-order Marc's book, and please do so. And I will also place the link where you can find upcoming CFIC events. Now, with all that preamble completed, I now bring you Marc. And let me unmute you. There you go, Marc.
Okay, perfect. Thank you. Okay, well, hello, Center for Inquiry. Thank you very much for inviting me to come speak to everybody. Seeing groups like these and other pro-secular, pro-science groups, seeing groups like these still thriving despite a global pandemic where group members still feel dedicated enough to tune into a virtual meetup instead is just fantastic to see. Groups like these are only becoming and will become more and more important over time, the more the world becomes just beset by misinformation and a multitude of narratives out there that anyone can listen to out in cyberspace, on the news media, and on social media, which is fast becoming our new mainstream media. It's just so crucial that people like all of you are out there, walking around, who love to learn about complex topics, and love to read, love science, and love to have difficult and sometimes nuanced conversations. But anyway, so I'm Marc Schaus. Some of you might know me by my first book, which was Post-Secular, Science, Humanism, and the Future of Faith. For anybody who didn't catch it, that book is essentially all about me discussing all of the evidence out there that I believe can explain why we see some social groups around the world becoming more and more secular over time, and why those trends seem very likely to continue well into the far future, provided we don't undergo some kind of mass civilizational shift in the developed post-industrial societies that we live in. So that was Post-Secular. And for anybody who did read it, the good news is that I've stayed up to date in a lot of the research in the book, and I am happy to report that new information has not yet come out to overturn my hypotheses in the book. So that is always very good. It is, I can assure you, a science writer's worst nightmare when you put your name on a theory and, put your back into doing all the research that goes into it and try and pump it out to as many people as possible and, try and tell everybody, hey, I found a, meaningful pattern in this data and here's why it should mean something to you. It's your worst nightmare to potentially have some new information come out in, a year or 2 years or something that would, throw into question some of your main assertions. I mean, obviously you love to see the advancement of science nevertheless, but you always want to stay on the right side of it for as long as you possibly can. So fortunately, the good news is that that has not yet happened here. Pertinent now, why I've been staying up to date on all that research is that it is very much my job to stay up to date on a lot of new research. So I don't really get into depth in that book, or usually often in many of my lectures, what my day job actually is. I mean, I've 3 different jobs, but the one from which I derive the most meaning in life is being a research specialist, which is essentially being a researcher for hire. So I've gotten out of doing neuroscience all in because I found I get quite a few gigs on the side doing research for hire for lots of different people and groups, for postdocs working on their dissertations, or profs looking to augment their research team, or companies that want to put out a product manual and want a science writer to draft up the technical specs for it, nonprofit organizations that are putting out their own kinds of publications, research groups that are writing grant proposals to convince other people who might be, lay people in their research, but with access to capital, why they deserve, a little bit more of that capital to continue their research. So it's very much my job to stay on top of a lot of the new releases coming out of academia in terms of new experiments, new analyses, new reports, and things like that in a variety of different sciences. So anything from neuro and nanoscience to biotechnology and molecular engineering, just to have something relevant to say in the event of work. So that generally involves day to day, week to week, month to month, and year to year, combing through all of the latest releases coming from around academia. So that has given me, I believe, a unique perspective on which major advancements have come out of the world of science over the past several years specifically, and which developments are coming up realistically just over the horizon. Specifically, in 2 areas, I found, like, doing that year in and year out, I kept seeing a lot of good news. So, I mean, that sounds pretty intuitive. I mean, scientific developments, good news. We love to see the advancement of science. But in 2 areas specifically, I found I kept seeing more and more good news, which was advanced technology and climate change. So that probably sounds a little bit less intuitive, good news, climate change, right? Because, I mean, the coverage that we often see of climate change in the news media and on social media is unilaterally negative, right? So, I mean, the imagery that you're most likely to see tapping into any coverage of climate change is probably just our world under siege somewhere, anywhere that we want to look. And so maybe most of you, if you're trying to conjure up images of what climate change is and what's happening around us, it's probably something just horrible, right? It's probably, maybe you picture floodwaters threatening World Heritage sites, right? Maybe you picture the floodwaters, say last year in Venice, that were submerging the plaza that was right outside of St. Mark's Basilica, where tables and chairs are floating away and floodwaters got down into the catacombs. Or maybe you think of those floodwaters threatening major cities, right? Maybe you think of New Orleans, where even in suburban neighborhoods, many miles away from the coast, people would find their homes like half submerged underwater. And you'd see them in the media canoeing to and from their homes, or far more often probably stranded up on their rooftops with messages for help splayed over bed sheets for the rescue choppers passing by overhead or something like that. Or maybe you think of the seemingly never-ending wildfires that are just ravaging places like California, or the Amazon or Australia or our own Alberta and BC. Or, I mean, maybe you think of the science. Maybe you think of the new reports that always seem to come out where the scientists acknowledge that things are happening far faster than we thought they would, right? Where, you know, glacial melting happening faster than predicted, rise in global temperatures happening faster than predicted, biodiversity loss and species extinctions happening faster. Like, it's like we're getting a prize every time they say the words faster than predicted, right? Where the whole perception of climate science, it seems, is just never-ending bad news, punctuated only occasionally by the not-so-bad news, in the words of atmospheric scientist Catherine Hale. But so that's one reality of looking at climate change. Like, it's a very real reality because all of that's very true, but it wasn't necessarily the reality that I was seeing in my day-to-day just analyzing scientific development, where if much of what I'm reading about is, say, new advancements in renewable energy technology, new advancements in carbon capture technology, one of our, you know, most wasteful industrial processes getting made slightly less wasteful or something, it's a different kind of reality. It's one of hopes and innovations and things that we can do. And it didn't really square with the other reality that I was seeing. And for me, I mean, if you're like me and you stake your beliefs where we have data, where the evidence goes, wherever the evidence goes, those tiny piecemeal new developments were the only thing that ever gave me even the slightest shred of feeling that we were not utterly ruined by climate change. Because, I mean, the moment you go and listen to what the scientists are saying, and, you know, you go and listen to the atmospheric scientists and, you know, people, you know, reading global temperature data and Earth's carbon cycle and hydrologists and marine biologists, like, we have a converging consensus of scientists telling us that we really are in quite a lot of trouble now. And the moment you go to, you know, like, read those reports and listen to their lectures and tease out some of the most, you know, some of the more extreme voices on any particular issue, the real just empirical data we have tells us their situation truly is quite bad, right? So they're at least not lying to you about that. The scientists, or at least the consensus, is certainly not lying to you about that. People like, you know, climate activists, major climate activists usually are not lying to you about the size and scope of our problem. Like, Greta Thunberg is not lying to you about the size and scope of our problem. And whatever you might think about climate activists and, you know, political issues like carbon pricing or cultural issues like, you know, the campaign to rebrand climate change as climate crisis and things like that. Whatever you might think about those things, we do really have a lot of scary data that's hard to argue with or look away from. So, I mean, the decade of years, for example, between 2010 and 2020 was the hottest decade that we've ever had on record since we started measuring these things consistently. 2016 was the hottest year ever. 2019, just last year, came close to topping it because right around this time last year, we were just getting into the hottest June ever recorded. Last July was the hottest month that we have had on record. Let's see. Last September was the hottest September ever. Last October was the hottest October ever. Last November was the second hottest November ever, and last December, hell, it was so hot in Australia, one guy was able to cook an entire roast pork in his car, right? So, I mean, those things are all very real and very scary, right? So, I mean, the oceans really are slowly turning to acid, right? I mean, they sponge up excess CO2 from the atmosphere, and the subsequent chemical reaction leads to more acid in the water. And as hot as our new global temperatures feel to us on the land, the oceans actually absorb the vast, vast majority of the global increase in temperatures, and massive marine heat waves are just devastating marine ecosystems. And there's a lot of other things happening from the increase in heat, like some of the moisture in our soils is more likely to evaporate, and we lose nutrients and things that we're trying to grow to eat and sustain ourselves. and the increase in extreme weather events that we've been having over the past several years. I mean, obviously we can't tie every new superstorm directly to climate change specifically, but we now have voluminous data that tells us that the increase in extreme weather events that we've been having over the past several years specifically is intricately linked to our planet's changing climate, and that they're probably going to get a little bit worse and a little bit more frequent in years to come. And I mean, some of the most apocalyptic climate scenarios that are being floated around out there, I don't tend to believe that a lot of those will come to pass, because I mean, probably the most richest people in the world probably are not going to allow their world to just become ruined, but realistically, some very apocalyptic things could happen to the rest of us, right? I mean, you could see a heat-induced crop shortage somewhere coupled with a dried up aquifer for water shortage, and then a displacement of people possibly due to an extreme weather event. And what you'd have from a threat multiplier like that is a humanitarian crisis that could be so bad that it could realistically draw some of the world's elite militaries into a sustained and ugly conflict, right? So all of that is very real and very serious. However, in the probably now immortal words of Greta Thunberg, we've clearly been sailing with climate change, but we have not yet sailed in the past tense, right? So that's all very real, but getting back to the good news version of reality that I was seeing more in my own daily life, as societies like ours have come to recognize climate change as the massive existential threat that it is, we've been pumping more and more scientific R&D funding into the scientists and engineers that are actively working on solutions to some of our biggest problems. And so the trickle pace of some good news here and there, something that would make me sit back and think, oh, that's good news that somebody developed a small new innovation on renewable energy technology or carbon capture technology. Maybe it doesn't solve our whole problem, but or even that problem specifically, but it at least gets us slightly further from where we were yesterday. That trickle pace of new developments here and there has sped up considerably over the past several years because we simply have more people working on these things. And it's made it more likely not only to see good news in general, but that I'd once in a while, here and there, see some really good news. A new development that would make me sit back and think, wow, that could be a game changer. Maybe we actually do have this. I see a new scientific headline like, scientists develop new carbon neutral fuel from sunlight and air. What? What? I mean, if that's real, I mean, a headline like that should be breaking the internet, right? Except it was real and it never did break the internet because I don't think that it was amplified to the degree that it probably should have been. Or a new headline like, scientists develop new technology for turning landfill trash into jet fuel. Okay, all right, now we're talking. That could make a difference. Okay. Scientists develop new means of harnessing turbine spin underwater with access to Earth's essentially never-ending tidal movement. Okay, more of that, please. Scientists develop new super-fast drilling technique for tapping geothermal energy wells for more access to 24/7 thermal energy. Fantastic, keep that coming. Scientists create new organism able to convert waste gas emissions from industrial emitters into vehicle fuel. Okay, stunning. Scientists create novel strain of cyanobacteria able to simply exist in a vat of water lapping up sunlight somewhere, metabolizing vehicle fuel from there. Fantastic. Scientists create new source of protein from CO2 and sunlight. Well, that sounds like good news for the world's still growing population. What else? Scientists create new transparent solar cells that can just double as windows. Scientists develop new indoor solar cells that can harvest lower levels of indoor ambient light. Or how about this? scientists develop new means of converting excess solar and wind energy into a storable form that we can use when the sun goes down and when the wind is no longer blowing, right? So as new developments like these have come in more and more consistently over time, that reality has been able to convince me that we are not yet utterly ruined. But the problem is that new developments are coming in so quickly now that even if the mainstream media does cover a new development like that, I mean, if you're not actively paying attention to these things in the day-to-day, that can get washed away by new headlines, probably more negative headlines, and it becomes easy to miss the fact that we do have some very intelligent people out there that increasingly recognize that our world is on fire and are doing something about it and aren't just going to take that laying down. It becomes easy to miss the fact that we have brilliant scientists out there who are working actively on saving the world. So that's the new book, How Scientists Realistically Intend to Slow Global Warming and Actively Reverse Climate Change Over Time. So they won't just be able to roll back the clock on a lot of the environmental damage that we've done already, but scientists can realistically, certainly, at least work to remove the conditions that we ourselves have put there and at least reverse the engines that are driving the environmental destruction we see. Okay, how are they going to do that? So, I suspect probably that most or possibly even all of you are probably aware that climate change is caused by an excess of greenhouse gases in the atmosphere. So greenhouse gases like carbon dioxide, methane, and nitrous oxide, we have pumped too many of these in the atmosphere, or we have allowed too many of them to seep into the atmosphere, where they absorb more thermal energy, and the effect for us below is very much like putting on a thermal blanket, right? So that increase in global temperatures then leads to a cascading series of other effects that we see. But that excess of greenhouse gases, that right there alone is essentially much of our problem right there. So it's not our entire problem, that's much of our problem right there, that we've been living these lives of unparalleled luxury compared to past generations. And while there's nothing wrong with that per se, we've just always been burning some very dangerous kinds of fuel to make it all happen. So fossil fuels like coal, oil, and natural gas, which when burned release CO2, adding to the greenhouse gas problem. And that's not, again, the entire problem, but the burning of fossil fuels and releasing CO2 emissions is an oversized part of the problem. So for a long time, people obviously didn't really know any better in terms of what we were doing, how we were living our lives. And by the time we got around to listening to the scientists on the issue, we were already in pretty deep. So we'd already pumped many, many decades of CO2 emissions into the atmosphere. And we are now, at this point, systemically, institutionally reliant upon fossil fuels just for the basics of our everyday lives. I mean, everything about how we live is still very embedded in fossil fuels. Everything from the clothes you're wearing right now, or, well, it's virtual, I'm guessing there. But I mean, everything from the clothes you're probably wearing right now to the breakfast cereal you had this morning or the tablet that you might be streaming this conversation on, all of that is deeply embedded in fossil fuel use. So what can we do? So a consensus of scientists tell us that there are two things we can do to solve the climate crisis. First and most importantly, that we need to stop using fossil fuels as quickly as we possibly can. They're telling us we are very much in a hole with how much carbon emissions that we have pumped into the atmosphere already, and they're telling us that as we find ourselves in a hole, the very first step is just to stop digging yourself deeper and to transition to clean energy sources as quickly as we can. Now, I mean, clean energy sources don't necessarily have to be traditional renewables like solar and wind. They could be things like hydrogen fuel cells and nuclear energy, which are both emissions-free when they're used. We have a whole complement of options to realistically power a post-industrial civilization like ours with clean energy, and they're increasing every day. But they tell us there's a second problem here, that because we've already been blindly pumping decades, many decades of CO2 emissions into the atmosphere, that even if we do transition to clean energy sources, we'll still have quite a lot of CO2 up there, which will keep the planet about as warm as it is now, which is already too warm. So you increasingly see organizations like the IPCC, the Intergovernmental Panel on Climate Change, in their newer reports will say things like, en route to, through most of our mitigation pathways towards our clean energy goals, that we'll probably need to deploy what they call negative emission technologies along the way to draw down some of the greenhouse gases that we've released over time. So these negative emission technologies are essentially just a suite of options that we have, both high-tech and low-tech, all geared around reducing the amount of atmospheric greenhouse gases that we have in the atmosphere, and that we probably need both of those strategies going simultaneously if we want to not only stop the problem, but avoid some of the worst environmental damage that we could otherwise face. So all of the good news that I was seeing from month to month and year to year was any new development that would realistically move us closer towards achieving either of those two goals. So new renewable energy tech developments getting us closer to the first goal, or clean energy tech developments, I should say, or new carbon capture tech developments getting us closer to the second goal. So I mean, in terms of renewable energy tech upgrades, I mean, I'm talking incredible new materials that we can put in solar cells that allow us to harvest more of the sun's energy than we ever thought we could before, or allow, record-shattering new efficiency levels, or new manufacturing techniques that allow us to doggedly pull down the costs over time, to more realistically allow any particular individual or company or country to want to power their lives with solar energy. And I mean, cost reductions and manufacturing tech upgrades does not always necessarily make for the sexiest book content or lecture speaking material. But I mean, for me personally, that is a huge part of the engine that drives us towards realistically achieving the 100% coverage of a society like ours with clean energy. I don't really believe that moralizing people into using clean energy will necessarily achieve the global systemic change that we want. It's much more, to me, market forces that take over and make it seem like a no-brainer that you want to power your home or business or country with an energy tech like solar energy. So I mean, when we have, say, a new report come out from Bloomberg last year that says it is now cheaper for 2/3 of the global population to power their lives by building a new solar farm than it is to build a new coal-fired plant. I mean, not just more eco-friendly, not just more environmentally conscious, but cheaper, more profitable. That to me is sexy content. I mean, when you have an analyst last year from the World Economic Forum saying that solar energy tech is now so cheap that the world will be manufacturing tens of thousands of new solar panels per hour for the next 5 years, that to me is sexy content, because those developments for me are what will really help to push the needle forward. But in terms of wind energy tech, I'm talking about things like, bigger, better turbines, new turbine, being built in larger than the Empire State Building. I'm talking about new developments for hydrogen fuel cell tech that would make it any more likely that people want to drive a car that's outfitted with hydrogen fuel cell tech, or to possibly power an entire building or an entire community with hydrogen fuel cells. With, I mean, like, realistically, well, what happens in a hydrogen fuel cell car when hydrogen is mixed with oxygen to produce the kinds of energy that we need? I mean, what comes out of the tailpipe of a hydrogen fuel cell car? It's not CO2 emissions, it's not pollution, it's water. Like, it's clean, drinkable water. Like, what comes out of the tailpipe of a Toyota Mirai? It's water. I mean, they tell you probably shouldn't drink it because it supposedly doesn't have all of the minerals you would get in normal, the normal water that we drink to sustain ourselves. They don't recommend it, but I mean, that is the only byproduct produced. So any tech development making it more likely that we can run not just vehicles, potentially even a whole society, something that Japan is betting on huge right now with hydrogen energy, it definitely qualifies in the good news category. Or I'm talking about new advancements in biofuels that combine some of our most advanced sciences like genome editing and biotechnology, right? So I mean, not at all. This is an example that usually comes up in conversation with other people that when they are familiarized with things like biofuels, not at all, you know, what was illustrated in the new Michael Moore documentary, if anybody gets to see that, you know. So I mean, not the palm oil plants, I think in Brazil maybe was what they were covering, you know, that were particularly ill-conceived and wasteful. That is not at all a fair representation of the potential of biofuels. I'm much more talking about bioengineered superalgae and novel strains of cyanobacteria that just exist in vats of water somewhere, where you don't have to demo large swaths of rainforest to make way for one of those processing facilities. And I'm talking about new advancements for things like nuclear energy that move us a little bit further away from nuclear fission energy, which, you know, much more of us are familiar with. A nuclear fission plant, you know what I mean, where they could possibly melt down, where Homer Simpson works, right? Much more towards nuclear fusion energy. It's a lot safer, proliferation, you know, resistant, and can't result in a thermonuclear explosion, right? So any new developments moving us realistically more towards nuclear fusion, again, fall into the good news category. And I mean, there are also a surprising number of other innovative, emerging, almost sci-fi clean energy technologies that are coming out of academia right now. Anything from, you know, using the waste heat from our electronics to power other electronics that then don't need a grid supply. Anything from harnessing the electrostatic energy in the air to possibly my favorite of the emerging sci-fi clean energy development of trying to harness the energy from electroactive microbes, strains of organisms that shed electrons just by sheer virtue of being alive. It could possibly be bioengineered to be a much bigger part of the clean energy portfolio. So I'm talking about things like that. When I'm talking about new developments that would lead me to believe that we can realistically power a society like ours with clean energy sources. So I mean, getting into depth on any one of them in particular, solar power, yeah, solar power, everybody's favorite, solar power. So I'm talking about, I mean, obviously, yeah, incredible new advancements in materials that allow us to harvest more energy and lower manufacturing costs. But for me specifically, I mean, cool new developments that make solar panel technology seem like slightly more of a no-brainer are when we can make them do new things or possibly put them in new places, right? So, I mean, solar energy now is so cheap that we have clever engineers experimenting with where they go around the world. So we have engineers working on, you know, solar bike lanes and solar roads, and they can experiment putting solar cell technology in interesting new places that confer side benefits that we didn't actually know about because we weren't putting solar technology in those places before. So you have new fields like agrivoltaics and, you know, putting solar cell tech in farm fields and seeing how that can augment and conserve, you know, land space and things like that. Or putting solar cell tech on buoyant pads that just float on bodies of water, where if you can do that reliably and safely because the technology is so cheap, we find that there are a number of side benefits to doing that, where the cooler temperatures of being around the water lead to an increased efficiency for the solar cells themselves, or, you know, all of a sudden you're not demoing huge areas of land to make way for all of the industrial infrastructure so they can be a little bit cheaper and cleaner, and suddenly countries that don't necessarily have a lot of land mass to spare but plenty of coastline can suddenly get in on the solar game. And now you have various countries around the world developing these little solar islands that not only augment their grid supply, but get into doing other things with solar cell technology at the same time. And when you can make solar cells do other things besides just produce energy, that to me just makes it seem much more likely that people are going to want to get one. So I mean, you have, say, a new line of solar panels. It's out from a lab-turned company down in the States, down in Arizona, where their new line of solar panels will not only produce electricity for your home off the grid, but they will also corral the moisture, to gather the water in the humidity and ambient air, to gather for you clean drinking water for your household. That's ridiculous. I mean, these so-called hydro panels, as they're being called, will generate between 2 to 5 liters of clean drinking water per panel per day, relative, obviously, to, you know, your access to sunlight and you know, the surrounding humidity and all that. But that's already fairly ridiculous. I mean, you could run a line straight to your tap, or you could monitor your water levels via app and go harvest it whenever you want. But if you could say to a homeowner, not only can you offset part of your monthly bill, and it's cheaper to get one now, but they can also do other things like provide you with some water, and you can potentially even commercialize some of your excess energy. That, to me, just makes it so much more likely that somebody's going to want a solar cell up on their rooftop. Or, I mean, in terms of new developments in solar energy and rooftop panels specifically, I mean, one of the coolest new technologies, I think personally, that I discussed in the new book is so-called anti-solar cells that will allow us to harvest energy from our rooftops overnight after the sun goes down. So, I mean, scientists are able to do that by taking advantage of an effect that physicists call radiative cooling. So essentially the idea behind radiative cooling is that sunlight hits our planet's surface, and I mean, a lot of that is just reflected off back into space, but a non-trivial amount is absorbed on the surface as thermal energy. So over time, that thermal energy dissipates back into space, especially overnight. And the idea behind anti-solar cells is to capture, as that thermal energy is going back out into space, is to capture it on its way back out and harvest a little bit of electricity with a thermoelectric generator. So, I mean, obviously, that is less energy than you will generate with a traditional solar panel. So, I mean, I believe it's about 25% of the energy that we get with a conventional solar panel, but that is still a marked improvement over the 0% energy that we are harnessing from the night sky currently, right? So developments like those realistically just nudge us just bit by bit towards more realistically covering 24/7 clean energy supply for a society like ours. Wind energy, too, has evolved considerably over time here and there. So, I mean, your average wind turbine today has evolved to generate about 100 times what models from the 1970s could generate, while simultaneously costing only about 10% of what it used to cost to harvest that electricity per kilowatt hour, right? So, I mean, the world's largest wind turbine actually just went up a couple of weeks ago, has blades longer than football fields. So scientists studying wind energy over time have allowed us to try and craft our designs to better harness more wind energy and harvest it more predictably. So they tell us that if we could just get the turbines taller, where at higher elevations we get greater wind speeds and slightly more predictable wind speeds often, or if we can get the turbines offshore, where again you have slightly faster wind speeds and slightly more predictable wind patterns. Predictability with wind energy goes a long, long way towards making them marketable. So I mean, you could have, say, a smart grid run by AI and machine learning that links to a network of weather sensors that are all around turbines or even on the turbine itself that could detect even micro dips in wind speed and send that information back to the smart grid to then more intelligently allocate and delegate energy. So, I mean, you know, the TV won't turn off when the wind dies down or whatever the critics were saying last year, things like that. And in terms of fancy new developments in wind energy tech, they're proceeding slightly slower than solar energy tech, which has gotten even more cheaper over time than wind energy tech has, but they're still progressing. So, I mean, you see labs and companies around the world experimenting with innovative new designs like, you know, quick deploy energy kites. You know what I mean? They can bob and weave in the wind and turn a tether attached to a turbine coupled with an electric generator, where, say, a lab picture of something like that costs a lot less than your average wind turbine and could be actively deployed in a disaster-stricken area with down power lines to still contribute some clean energy, or in poor or rural development areas where, you know, maybe they don't necessarily have the capital for a massive wind turbine, but still want just slightly more clean energy, augmenting their portfolio of other supplies. You also see labs experimenting with things like drone technology, where lighter and more durable materials have allowed us to more effectively hit that cost-benefit ratio of deploying drones that, say, can harness more wind energy just by sheer virtue of being airborne and moving. But obviously that's just an emerging technology, and there are a few others that I discuss in the book for wind energy specifically. I mean, covering any of the other ones in depth would probably take me fairly into the weeds on any of them in particular. I'm not going to run over this time. Okay, but in terms of renewable energy tech developments like those, and we discussed those, critics of renewable energy sources always want you to think that the Achilles heel here is that no matter how good they get, the Achilles heel is that the sun goes down eventually, and we don't have, you know, a predictable supply of windy days, as though somehow scientists have not yet been planning for the fact that that we have nighttime. So I mean, some of the best new developments that I like to describe in the new book will help to augment those conversations, or hopefully help to put some of them to bed, where a new class of technologies, so-called P2x Technologies, where that's an acronym that stands for power to something, where you know, X is a variable, solve for X. So power to something that essentially take the idea that in areas where sunlight is plentiful while it's around, wind is plentiful when it's around, those places realistically have more renewable energy than their grid needs while those sources are around. And that as technologies like solar and wind become cheaper and cheaper, more communities will have more input scattered around their communities to also approach that level, where when the sun is around and the wind is blowing, they realistically get more than their grid requires, even during peak hours. So the idea behind P2x Technologies is to take that excess renewable energy that we get during times of plenty and use it to perform work, right? So as you know, human animals, we understand where our needs are going to be in a civilization like ours, so we can use excess work to perform work that we know that we're going to need down the road, and then won't necessarily need to allocate grid energy for, or much more often, they're about using the excess renewable energy during times of plenty to create potential energy somewhere else that we can then turn back into usable energy when the sun goes down or the wind is no longer blowing. So I mean, an example of that would be, say, hydroelectric energy. So we use the power of moving river water to spin turbines coupled to an electric generator to supply ourselves with electricity. But communities don't always get the amount of energy that they would like to have from a source like that. So somewhere along the way, clever engineers realized that if they just diverted a little side channel and during lesser need times pumped some of the excess water up to an elevated position, that they could just keep it sitting there. And essentially, like a water battery, could just have that sitting there so that during times of need, that could be released onto waiting backup turbines, coupled to waiting backup electric generators to supply more grid supply of energy when people need more energy. But obviously not everywhere has access to a major river to supply themselves with a backup solution like that. So new innovations in that kind of energy storage design. You see some labs and companies now experimenting with the idea of, say, artificial lakes on you know, the city boundaries, where you could have an artificial lake, and during times of plenty where we have excess renewable energy that's not necessarily getting used, to pump that water up to a higher elevation, or pump it into a subterranean chamber where the water pressure can be released, or elevated water can be released during times of need, again, to move turbines coupled to electric generators, putting the water essentially back to where it began, so you could start that again the next day or the next week or whatever. Or one Swiss company has experimented with the concept of what are essentially gravity batteries, where they take excess renewable energy during times of plenty and use it to hoist essentially weighted blocks in a controlled chamber, where those blocks just then sit there. And then when a smart grid detects that we're going to need just a little bit more energy, those weighted blocks can be released or lowered slowly to pull on a pulley coupled to a turbine, and you get the idea. And the wonderful thing about designs like those is they can be built anywhere. Anywhere on Earth you could build, essentially looks like a silo. Anywhere on Earth you could build a design like that, and something like the potential energy of a raised weight will not degrade over time, unlike, say, the chemical energy in a traditional battery, or possibly the thermal energy in a heat storage site, things like that. One company specifically, actually, that's taken another innovative new direction with that kind of scheme is a local company right around where I am, near Toronto, and they essentially riff on that idea by taking excess renewable energy to power up air compressors, which then pump pressurized air into specially designed chambers, where when we need more energy, that compressed air can then be vented out in controlled amounts to, again, force the movement of turbines coupled to electric generators. And this company in Toronto had solved some of the trickier engineering challenges that allow them to maintain predictable flows of air pressure and some of the other problems. So things like those are always good to see. But I mean, we have a whole class of those and like-minded P2x technologies that get us just a little bit closer, if deployed, to realistically store enough energy to power our society, after the sun goes down or when the wind is no longer blowing. And some of them are so emerging sci-fi that they could revolutionize our society in unpredictable ways. So one of the cooler P2x style technologies that I talk about in the new book, let me just see if I have time to talk about this. Oh no, I'm getting close. Okay, well, green hydrogen is one of the more fascinating applications of P2x technology, because hydrogen fuel cell technologies, like I was saying, we can use those on essentially anything from cars to vehicles, cars and vehicles, anything from cars to buildings, to whole communities. Except the problem is that hydrogen, as abundant as it is, the most abundant element actually, as abundant as it is, does not usually appear in isolation for us to just go harvest. So it's usually attached to other molecules. So take a molecule like H2O, water, where H2 is the hydrogen there, and O is the oxygen. So I mean, we have a plentiful source of hydrogen on our planet technically, but scientists need to first separate that out. So enterprising scientists found along the way that if they ran an electric current through water, perform electrolysis, that they can separate it out into its chemical constituents and then shuttle away the H2 and the O to different locations. So that's one way of more or less generating hydrogen that we can then use. And if those electrolyzers are powered by renewable energy inputs, that's why they call it green hydrogen, because it's green energy. But that hydrogen can then just be stored and used in hydrogen fuel cell technology anytime that we want. So that will be one of the more transformative new P2x style technologies. Scientists just have to solve some of the trickier engineering challenges of doing that en masse and on a scale where we could actually augment global energy with hydrogen fuel cell technology. Obviously, it would be very good if politicians set some policy levers in place, like more R&D funding and more, possibly subsidies for that kind of technology, which is what solar and wind needed to get to the impressive point that they are today. So all of those kinds of technologies get us realistically closer to solving challenge one, powering our civilizations cleanly and sustainably. Problem two, the atmospheric greenhouse gas problem is infinitely more difficult than problem one, because I mean, if researching this book has taught me anything, it's that the easiest way to remove a greenhouse gas from the atmosphere is essentially just not putting it there in the first place. But what I've also learned from new developments and things like that is well, actually, one of the most surprising things I learned is that we have the technology to do this right now, today. That right now, today, we have the technology. It's not always as sophisticated as we would like to do it at large scales, but we have the technology to chemically scrub CO2 from ambient air, even in concentrations that are as dilute as the atmosphere, where, I mean, 415 parts per million, that's way too much CO2 for animals like us on the kind of planet that we want to live on. But I mean, in terms of the entire atmosphere, that's still very dilute. So we're talking about parts per million, but we already have the technology to chemically scrub that out. It's just been deemed too expensive to even want to start to roll out in piecemeal solutions. So I mean, too expensive, despite the hundreds of billions of dollars that we'll likely spend on eco-restoration efforts following extreme weather events. Too expensive, despite whatever price you want to put on lost human, lives and livelihoods. Too expensive, despite whatever price tag you want to put on lost world, heritage sites in the event that they get wiped out. Too expensive. So new developments in that area are from scientists trying to develop new ways of doing those things to make them more expensive. But not only that, but for me, being what I like to believe, as a realist and a pragmatist, big new developments in that area are scientists trying to turn CO2 into a marketable product so that market forces can take over and incentivize heavy emitters to want to capture their carbon. So as it turns out, carbon is a chemical precursor for a lot of value-added chemicals, and that we have new labs and companies focusing on ways of taking CO2 and upcycling it into something else that they can sell. So if they take something, something like CO2 and split it into CO, carbon monoxide, they can couple that with, say, methane or hydrogen or other things to create things like fuels or plastics or fertilizers and things like that. So you have some of the new companies that I write about in the new book, they'll come to a heavy emitter and fix onto their, industrial apparatus, essentially a washing machine-sized tech that will capture some of the waste emissions and pipe them away, where a company like them can try and upcycle them and make some money off of it. And then either the industrial emitter can, either get in on some of that revenue, or much more realistically, because carbon taxation has proven to be a useful tool in motivating people to not want to emit, more realistically, heavy emitters can just avoid getting taxed on what they emit. So you see an approach like that in Trump's America, where, he doesn't want to mention the word carbon tax. So instead, they've put new, tax provisions out that will give out kind of a subsidy for people to capture their carbon to help. And I mean, as much as anyone might want to, complain about the Trump administration in terms of environmental terms, a new tax provision like 45Q will be huge in helping to augment an emerging industry, like trying to turn captured carbon into a global industry. Efforts like those could possibly be huge in helping a fledgling industry like that get started. But anyway, so direct air capture, which is what they call, capturing CO2 in ambient air, or in waste emissions, carbon capture, that's just one of the potential solutions that clever engineers and scientists are working on around the world. But we have a whole host of other options, and they range along a trifecta of safety and land use and cost, and probably another, factor of the speed with which they will be able to allow us to get started on rectifying our situation. And some of them are better than others in those different regards. So, I mean, one of the cheapest, most natural options that we have for drawing down atmospheric CO2 is something that people have been, some people have been telling us to do for quite a long time now. Is simply to plant more trees. Where, we didn't necessarily need advanced scientists to tell us that planting more trees would help us solve the CO2 problem, because, I mean, trees is part of their life cycle. Trees and crops and other vegetation will absorb some CO2 to power the rest of their photosynthesis process to gain energy, and they will store that carbon when they create what's called biomass that we then see as, bark and twigs and leaves and things like that. And when a tree dies, much of that carbon is then released back into the atmosphere, but a portion of that carbon is stored down in the root networks, where it's stored in the soil for much longer periods of time, giving us a brief reprieve in there from having that carbon be in the sky instead. So people who support mass afforestation campaigns to plant new trees, or at the very least just stopping all of the deforestation that we do now, that's the basic idea. But obviously, we would need a lot of trees to address a global concentration of atmospheric CO2. So, the good news is that scientists are telling us that we have enough land space left on this planet to plant over 1 trillion new trees, which those are numbers we're talking about in terms of solving, excess carbon in the atmosphere. And that even planting about 500 billion of those trees would wipe out about a decade's worth of our carbon emissions. So, those are just back of the envelope calculations from certain scientists around the world, so it's an emerging consensus. So, not everyone agrees with exactly how many trees we would need or where they should be planted. Sometimes it's better just to leave the land alone, where grasslands and biodiversity kind of lead to a greater carbon sequestration than if we just artificially throw in a bunch of trees and hope they grow. And obviously the other problem with that solution is that we require a lot of human capital to make that happen, right? Planting trees can be hard. Anybody who's ever spent time up north, hauling around saplings and getting them into the ground, that lifestyle is ruthless. Anybody who does that for about a season is probably looking for more work after that first season. The men and women who do that every year, these people are champions, right? So, scientists hoping to develop solutions for that problem are doing what scientists do best in taking humans out of the equation. So, as it turns out, we can equip aerial drones, either piloted remotely or set to autopilot, can use advanced vision software coupled with LiDAR to create 3D vegetation maps and sync that information with satellite data to plot out the best areas to seed new trees. And then those drones can then proceed to fire germinated seed pods directly into the soil on their own. They can do it much faster than we human planters can, and they allow us through afforestation campaigns to tap locations that were previously maybe off limits to human planters, like steep hillsides and things like that. And they do these things so fast that, some teams report thousands of seeds a day. Some teams report tens of thousands of seeds planted per day, where, one of the companies that I talk about in the new book, Dendra Systems in the UK, they tell us they're going to get us to that 500 billion new tree benchmark by the year 2060. So, good luck with that, right? So, they're far from alone in those kinds of efforts. I talk about close to about a dozen other drone-based eco-restoration companies that, a team of operators piloting a drone swarm can cover hectares in a day. So, those start to create the kinds of new tree numbers that we want to talk about, right? Otherwise, scientists working on other incredible new solutions for absorbing more atmospheric CO2 want to make that job even easier. So, we grow crops year after year, for example, just to sustain ourselves, and they work in much the same way. So, a portion of the atmospheric CO2 is stored in root networks and get absorbed in the soil for soil carbon sequestration. So one of the most fascinating, one of the most game-changing new ideas that I've seen out there and talked about in the new book is from one woman in her lab down in the States on the West Coast that is studying the way some crops and plants are better than others at storing soil carbon because they have larger and more diffuse root networks, and hybridizing those with crops that we would be growing anyway just to sustain ourselves. So either by hybridizing those naturally or possibly even bioengineering new ones that could allow us, just by sheer virtue of business as usual in terms of global agriculture, or possibly even in those afforestation campaigns, to slash the amount that we would need to grow for achieving the same kinds of carbon storage levels. So I was able to, fortunately able to correspond with her and her team. And from what I'm told, research is going very well. They are about, I would say now, 2.5 years into a 5-year research scheme to try and assess the ability that those kinds of solutions will have going forward. And even some of their rudimentary numbers cited that deploying those kinds of crops around the world could reliably absorb between 20 and 40% of our yearly carbon emissions. So, I mean, those, again, are absolutely new developments that will get us closer and closer to the seemingly Herculean task of addressing our oversized atmospheric CO2 problem. So, all of those kinds of solutions move us closer to the second goal, but I mean, ultimately, as I can see, I'm now getting pretty close to the ceiling here on my talk. Ultimately, the one lesson that I would want to share with anyone from this lecture or from the book in general is that we have brilliant teams of scientists working on very realistic solutions, and they're working on them right now. So, I mean, not just sci-fi technologies that could possibly come up in the next 10 years, but I would say it's probably about an 80 to 20 split in terms of 80% of the new tech that I discussed being not only possibly in existence right now and starting to be deployed, but right about to be deployed over the next year or two, and only that last, say 20%, like new advancements in nuclear fusion and things like that, which still, I mean, the engineers working on them say we could have a pilot project going by mid-2020s. It's still not super far off. But I mean, the fact that we have brilliant scientists working on these situations now and that they're working on making our world more livable in the short term. So on that note, the new book is called Our Livable World, and it will be out in October through Diversion Books. Okay, thanks, everybody.
Well, we're all giving you virtual applause, Mark. That was fantastic. That was very passionate. I think we all can agree on that. And it sounds like the book, if it's anything like your talk, is going to be quite amazing.